So if this one looks at all strange to you, that's okay. All right, this one is a little bit weird, but we're going to treat it just like we have all the others. So I've got 1 times xenon, and that's the weird bit, right? And 2 times fluorine. So now xenon is a noble gas. And you're thinking to yourself, but wait, noble gases are stable, so they shouldn't be making compounds, right? Yeah, that's in general true. Like neon very rarely, actually, neon never makes compounds. Helium, neon, okay? Some of the farther ones down, they can make compounds because they have access to the D subshell, all right? So it is possible for noble gases to make compounds. It's unusual, okay? They're usually like fluorine compounds because of the sort of unique characteristics of fluorine. So you just treat them like any other element, all right? And xenon has 8 valence electrons. So that's 8. And I've got 2 fluorines, which by now I know have 7, so that's a total of 14 for a grand total of 22 valence electrons. Okay, so which one do I put in the middle? Well, there's no carbon, so I have to use the least electronegative, and fluorine's the most electronegative, so it's going to be xenon. So I'm going to do xenon with a fluorine and another fluorine, don't worry so much about the shape, with 1 bond, and then I'm going to fill up the octets. So here we go, here we go, here we go. Okay, now I do my count. 2, 4, 6, 8, 10, 12, 14, 16, 18, 12. Uh-oh. So, hopefully, you counted and you realize that there was some sort of problem. If you didn't count, you just submitted like this, and you got it wrong. Okay? This is why the counting is so important. So, well, if I go back and I look at the periodic table, xenon is in the 3rd period or lower, so it can have an expanded octet. So xenon can get the 2 electrons, and now it has an expanded octet. The fluorines can't because they're in the 2nd period, so you can't put the extra pair over here. That would be bad. Okay? Always goes on the central atom. The extra pair goes on the central atom. All right? And there's going to be a lot of this kind of weirdness where if you don't do your counts right, you're going to run into some trouble. All right? Good problem here, though.